96 VLS cells sit empty on a billion-dollar destroyer, and each replacement Tomahawk costs roughly $3 million. It takes our defense industrial base 18 agonizing months to build just one of these highly sophisticated precision cruise missiles. The biggest threat to the US Navy right now is not the firepower of the enemy, but rather the deadly and unforgiving math of sustainment. Welcome to the era of asymmetric naval warfare, where firing your advanced weapon is exactly what the enemy desperately wants you to do. Somewhere in the vast ocean at 2 in the morning, a multi-billion-dollar warship swings its massive bow away from a hostile coastline. The exhausted crew inside is perfectly ready for combat, and the ship itself remains undamaged from the intense recent combat engagements. This incredibly powerful vessel must retreat because every vertical launch tube is empty, turning it into a vulnerable ocean spectator. Today, we will expose the classified mathematics of modern naval warfare and why the most powerful military is actively struggling to adapt. The mainstream narrative focuses entirely on the geographical distance a warship must travel to reload its weapons at a secure, friendly port. However, the true strategic crisis we are witnessing is the rapid depletion of high-tier munitions against massive swarms of cheap drones. The issue in the Gulf is not just firepower. It is magazine depth versus long-term sustainment in a highly brutal, asymmetric attrition war. We are currently deploying the most expensive legacy weapons of the Cold War era to swat down expendable unmanned aerial vehicles. This fundamental mismatch in economic military strategy creates a massive vulnerability that our adversaries are deliberately exploiting. An Arleigh Burke destroyer is an undeniable technological marvel, but its combat effectiveness drops to zero when the missile tubes go dry. The adversary knows they do not have to sink our billion-dollar warships if they can simply force us to exhaust our limited ammunition. A sophisticated defense screen becomes irrelevant when defensive interceptors cost significantly more than the cheap incoming threat. We are trading precious and finite combat assets for low-value targets in a strategic gamble that mathematically favors the underdog. Let us be incredibly precise about what those advanced launchers actually delivered during the recent intense combat operations. Over 850 cruise missiles were launched from American destroyers in the first 5 weeks of Operation Epic Fury. This is the highest number of cruise missiles fired in a single military campaign in the entire history of modern naval combat. The operation successfully dismantled the threat architecture and set the adversary back by several years of strategic development. Once the 96 Mark 41 VLS cells are depleted, the destroyer becomes a highly advanced spectator in the middle of a dangerous conflict. Every single missile that leaves its tube represents a critical loss of firepower that cannot be easily or quickly replaced at sea. The fleet burned through precision munitions at a terrifying rate that completely outran the logistical system designed to sustain it. We will not waste your time discussing the exact nautical miles to distant ports because the real issue is the speed of expenditure. This rapid depletion forces the operational commanders to make impossible choices between providing adequate defense or sustaining an attack. To understand why reloading at sea is so difficult, we must examine the terrifying physical reality of the open ocean environment. A warship on the water moves in 6 distinct axes simultaneously, including pitch, roll, heave, yaw, sway, and constant erratic surge. When a crane lifts a 3,500-pound steel canister packed with volatile rocket propellant, it creates a massive pendulum. The ship rolls violently to the left on a wave, but the heavy suspended canister swings dangerously to the right due to sheer inertia. This continuous correction lag between the unpredictable motion of the hull and the swinging cargo generates uncontrollable oscillation. You are attempting to thread a massive explosive needle into a 25-inch square tube while the floor violently shifts beneath you. Even a minor swing in moderate sea states easily exceeds the extremely tight clearance tolerances of the vertical launch cell compartment. One incorrect impact of steel against steel could easily ignite the volatile warhead, turning a standard reload mission into a disaster. For decades, the fundamental math of gravity and momentum flatly refused to negotiate with naval engineers attempting this dangerous task. The original video confidently claimed that reloading these massive weapon cells on the open ocean was completely physically impossible. The transferable reload at sea method, or TRAM, changes everything about how our naval forces operate in deep maritime environments. Unlike what outdated reports claim, the Navy's recent TRAM tests prove that VLS reloading underway is no longer a pipe dream. The brilliant engineers at Johns Hopkins Applied Physics Laboratory spent years developing this radical mechanical loading concept. They boldly rejected the deeply flawed premise of using traditional swinging crane cables to transfer highly sensitive munitions. This revolutionary new equipment successfully completed intense land testing in California before moving directly to ocean trials. This incredible technological breakthrough effectively shatters the persistent myth that a depleted warship must abandon the fight. Warships can now stay directly in the combat theater while receiving fresh guided missiles from specialized logistical supply ships. The innovative system completely eliminates the deadly pendulum effect by utilizing powerful and rigid hydraulic clamping jaws. Instead of suspending the explosive cargo from a swinging cable, the canister is securely locked to a customized rail system. This advanced rail framework is bolted directly to the vertical launch module structure on the deck of the rolling destroyer. When the massive ship pitches and rolls on the unforgiving ocean, the secure rail and the attached canister move together. A dedicated replenishment vessel pulls alongside the active warship to transfer the essential munitions using standard lines. Once aboard the destroyer, the hydraulic arms immediately seize the heavy canister and rotate it directly into a vertical pose. An integrated cable mechanism riding completely inside the rigid track slowly lowers the weapon into the waiting empty cell. The entire delicate sequence is controlled exclusively by raw hydraulic power rather than unpredictable gravity and momentum. While this amazing mechanical loading system successfully closes the dangerous presence gaps, it only moves the weapons. The fundamental crisis we face today is not about transferring heavy canisters, but manufacturing the actual missiles. Major defense contractors like RTX currently produce these sophisticated weapons at a deliberately slow peacetime rate. The industrial factories build roughly 90 precision weapons annually, while the combat fleet burned 800. We essentially incinerated 10 full years of meticulous industrial production in roughly 35 days of combat. The modern defense supply chain is incredibly fragile and heavily dependent on countless specialized subcontractors. Scaling a massive missile factory is absolutely not a quick software update that you can easily download overnight. It fundamentally requires intensive physical labor, highly trained human hands, and an endless supply of raw metals. Every single highly sophisticated cruise missile requires more than 100 specialized subcontractors to effectively build. The production lead time is anywhere from 18 to 24 months from the initial military order to the final delivery. You cannot just press a magic button to instantly accelerate the forging of raw materials and highly complex guidance systems. Thousands of incredibly precise components must be carefully assembled and rigorously tested before ever reaching the fleet. The harsh reality is that the physical laws of manufacturing do not accelerate simply because a violent war suddenly demands it. The mandatory time it takes to forge strong metal and assemble advanced propulsion systems is a rigid constraint we cannot bypass. This agonizingly slow production timeline fundamentally limits our overall ability to sustain these high-intensity combat operations. We are currently facing an unprecedented logistical nightmare where we consume advanced munitions much faster than we can make them. The fundamental mathematics of firing a $3 million missile at a $20,000 drone is absolutely terrifying. We are consistently using highly expensive legacy weapons from the Cold War era to combat expendable modern asymmetric threats. This completely unsustainable financial strategy inevitably creates a massive economic black hole for our national defense budget. Our intelligent adversaries do not actually need to destroy our advanced warships if they can successfully bankrupt our military. We must immediately stop utilizing premium precision-guided munitions to obliterate low-value targets and cheap unmanned systems. The terrible cost-exchange ratio heavily favors the enemy when we rely exclusively on our most sophisticated vertical launch cells. A fundamental transformation in our tactical engagement philosophy is absolutely required to survive this brutal war of attrition. We must fundamentally rethink our tactical approach and seriously consider bringing back traditional naval artillery. To survive this endless barrage of cheap drones, we need to mount effective gun systems on our modern warships. Engaging high-volume and low-value targets with conventional 76mm guns is extremely logical. These traditional weapon systems offer a significantly cheaper and highly sustainable method for fleet defense. We can completely obliterate incoming hostile swarms using standard explosive shells instead of smart rockets. By utilizing these reliable guns, we successfully preserve our precious vertical launch cells for major strikes. The strategic naval commanders must immediately recognize that not every aerial threat requires a missile kill. A heavy barrage of inexpensive metal projectiles can easily rip apart fragile enemy drones in the open skies. To counter low-cost drone swarms, the Navy urgently needs cheap and networked arsenal ships acting as missile mules. These specialized logistical vessels are essentially massive, floating magazines designed to carry hundreds of launch tubes. By deploying these heavily armed cargo platforms, we can drastically increase the total firepower of any given strike group. Advanced radar systems on our premium warships can identify targets and guide the weapons fired from these much cheaper utility ships. This networked combat architecture effectively separates the expensive sensor suites from the actual high-volume tactical weapon storage. Adapting basic commercial hulls to build heavily armed support vessels is the tactical solution our modern naval fleet currently requires. When the naval fleet suddenly runs dry during heavy combat, the incredibly powerful United States Air Force immediately steps in. Operation Rapid Dragon effectively turns standard C-17 cargo planes into massive Tomahawk delivery systems for deep strike missions. These converted transport aircraft can effortlessly drop specialized pallets packed entirely with highly advanced cruise missiles. A single heavy cargo plane can easily unleash an overwhelming barrage of precision weapons without requiring a billion-dollar ship. This brilliant cross-domain strategy successfully ensures that the enemy faces continuous destruction from multiple unexpected angles. By integrating heavy bomber tactics into the maritime strike plan, our military forces maintain a terrifying and endless combat tempo. The true military supremacy in the 21st century does not exist on the sharp bow of a billion-dollar warship. Genuine strategic power fundamentally resides within the endless manufacturing capacity of our defense industrial base. We must universally recognize that sprawling weapon factories are the ultimate combat platforms of modern global warfare. Global conflicts are ultimately won by the heavy industrial machines that physically forge the weapons of destruction. An advanced fleet, without a robust manufacturing supply chain behind it, is merely a terrifying but temporary illusion. National defense strategy must urgently prioritize mass production over isolated technological marvels on the high seas. We are currently standing at a terrifying crossroads where outdated military strategies clash with ruthless modern economic realities. The undeniable truth is that billion-dollar destroyers are fundamentally useless without a continuous supply of precision munitions. If we continue to aggressively burn through 10 years of missile production in merely 35 days, our fleet will surely fail. We must urgently accept that future maritime dominance relies heavily on mass production rather than isolated technological miracles. The pendulum problem was successfully solved by brilliant engineers, but the industrial base bottleneck remains completely unresolved. Our massive naval infrastructure must adapt immediately by integrating cheaper unmanned platforms to absorb the overwhelming enemy volume. Embracing heavy artillery and networked missile mules will ultimately prevent our premium warships from becoming irrelevant spectators. The Defense Department must decisively shift focus from building beautiful ships to establishing relentless and highly efficient factories. Only by mastering the brutal mathematics of asymmetric attrition can the U.S. Navy hope to survive the incoming wave of global conflict. This is the precise moment for our military leadership to make difficult and highly controversial decisions regarding fleet composition. We can no longer afford to casually throw $3 million interceptors at incredibly cheap and expendable aerial target drones. With Tomahawks taking 18 months to build and costing $3 million each to shoot down cheap drones, the math is getting ugly. I want to hear from you regarding this massive strategic dilemma our defense forces are currently facing in modern naval warfare. Should the U.S. Navy absolutely double down on networking cheap arsenal ships to effectively counter the incoming enemy drone swarms? Or is it finally time to bring back those heavily armored battleships with massive 16-inch guns for brutal coastal bombardment? Drop your detailed tactical assessment down in the comments below, and I will gladly pin the absolute best strategic breakdown.